between these two, they're about the same thing, except you got the OH, right? Two hydroxyl groups on the same side, on the opposite side or on the same side. So, right now, you got the fresh memory of the previous slide, so I'm pretty sure this is easy. But then later on, you should be able to remember that what reagent will do the job, right? So these are trans diol, 1,2-diol, that has to come from the oxide, at least, right? These two cis diol, that has to come from either osmium tetroxide or the permanganate. So first one, the trans diol. If you want to make a trans diol, you have to make an epoxide. That can be done by any peroxy acid, but MCTPase makes it easy. So if you choose to use that, fine. That make an epoxide, but that's not enough. You have to do it in acidic condition, acidic water. So you get protonadium, and then, in this case, it's both OH. It doesn't really matter, but the things that the more substituted side will lose more density. That's the one water molecule makes an attack opposite side. So this OH on the more substituted side, that's the one that comes from nucleophilic water. And then the hydroxyl groups on the less substituted side, that's the one come from the epoxy oxygens after we protonated. But that's how you make a 1,2-diol in trans relationship. If you want to make a cis, you cannot use this reagent because that reagent you get trans. So in order to get cis, you have to use either osmium tetroxide and hydrogen peroxide together, or permanganate and hydroxide, but cold and dilute. You have to specify cold and dilute. You're going to see if you don't do it in the cold dilute condition, then what happened later. So this is something that alternative to this, but you're going to get cis diol. It's not that bad once you know it, but you've got to know what pairs, as we discussed. A lot of reaction in these chapters are paired up. Adding HBr, regular way, or peroxide, radical way, right? Adding halogen like the bromine in the regular non-nuclear solvent, or you carry out the halogenation in water, right? And the hydration reactions, just oxymercuration, demercuration, or hydroboration reaction. So not all reaction be paired up. In this case, trans diol, epoxidation, and opening in acidic water, or permanganate or osmium tetroxide. So that's something that we discussed so far. I want you to remember these things. Many times people see this transformation, they see the hydroxyl groups here. And then some of you may think that, okay, I know how to add hydroxyl groups. That's oxymercury demercurations. So let's see what happens if you do oxymercury demercuration here. You got double bonds attacking the mercury, so you got the mercury ion mated, right? Same cyclic intermediate like this one, it's mercury. That's totally more density for the more substituted carbon, and that's the one that water molecule makes an attack. So backside attack. So almost exactly the same. But that only put the one OH. What happened to the other side? Mercury is replaced by the hydrogen by the sodium borohydride. So you get only one hydroxyl group. I know there's hydroxyl groups there. But if you your memories are partial, you choose a wrong reagent, you're not making this. You only put in one hydroxyl groups. So don't use this hydration reaction for making diol. It's a different reaction. And once this hydroxylation works, there's no double bonds. So you cannot do it twice. So you have to choose the right reagent. Another reaction that you might think about is actually hydroboration. BH3 can be added to double bonds, but this is a static reason. Smaller hydrogens are replacing the more crowded hydrocarbons. Larger BH2 is going to be added on the less substituted side. Both going to be added at the same time because of conservative mechanisms. You got hydrogen on the more substituted side, BH2 less substituted side. But this boron will be replaced by the OH in the next step, oxidation step, with the hydrogen peroxide and the sodium hydroxide. It becomes an alcohol, but just one OH, just like that one, single OH, not two. So if you have to make a diol in the adjacent carbons, you gotta use either this or that. You cannot simply mix them together. Just having an alcohol there doesn't mean that it can be done by anything, right? You gotta choose the right reagent. So that is something that I've seen a lot in the test, choosing the wrong reagent because you thought that I need to just add an alcohol, right? But the number matters, right? Are you adding 2 or are you adding 1? Anyway, so that is basically something that I would need to warn you.